All right, ladies and gentlemen, we're going to talk about Newton's three laws of motion. So how the motion of an object is affected by Newton's three laws. So we're going to begin with the first law. Watch this video. This is really pretty fascinating. It's a slow motion camera. That's kind of unexpected. So if we think about this in terms of the first law states that an object at rest will continue at rest unless acted upon by an unbalanced force. So these leaves are at rest. That's the example in number 1. The leaves are at rest. So when the person falls, the leaves stay in the same place essentially. The net falls out from under them, stretches out from under them, but they don't initially begin to fall. And then the net comes back up quickly enough that the leaves essentially appear to stay in the same place. So that's an example of Newton's first law, that an object at rest will remain at rest unless acted upon by an unbalanced force. If the net didn't come back up to support the leaves with a normal force, then the leaves would fall down and they would accelerate down at 9.8 meters per second squared. Then the next example is with this book, stack of books. The chair is going to be pushed back against the other stationary chair. Oh, and there goes the stack of books. So what you need to notice here about the book staying in motion is that the chair hits the stationary chair and the books don't stay there. The books just keep going in a straight line at a constant speed until they hit the wall. So the second example shows that when something is moving at a constant velocity, it will continue moving at a constant velocity unless acted upon by an unbalanced force. And in this case, the unbalanced force is the force applied by the wall when the books hit the wall and they bring them to a stop. Newton's first law is called the law of inertia. So what is inertia? Inertia is an object's resistance to its change in motion. And inertia is measured based on the mass. So if mass is the measure of inertia, then the unit that we would use to quantify mass and then describe inertia is a kilogram. So when we have something that's more massive, like this bowling ball, it will be more difficult to change its motion, more difficult to make it stop, more difficult to make it move, more difficult to change its straight line path. A less massive object like this basketball will be easier to change its motion. It'll be easier to get it going, it'll be easier to stop it, and it'll be easier to get it to move in a curved path. So this shows that kind of graphically. Compared with the more massive bowling ball, it will go in a straight line unless there's a force applied to change its motion, and that force has to be larger. We're going to do an activity in class with a basketball and a bowling ball, so you'll get a chance to kind of experience that. But for now, let's go on and talk about the next law. So Newton's second law. Newton's second law says the acceleration of an object is directly proportional to the force acting on it and inversely proportional to the mass. So let's look at that with this equation. So direct proportionality means that if force is increased in this equation, then acceleration will go up as well. That is provided that the mass stays the same. Similarly, if the acceleration is increased and the mass stays the same, then the force required will go up. So direct proportionality means increasing one variable increases the other variable by the same factor. Okay, direct proportionality. Then the inverse proportionality to mass, we'll see that by looking at these two values. That when we increase one variable, it decreases the other one by the same factor. So if force stays the same, if we double mass, then acceleration will drop by a factor of 2. If force stays the same but acceleration is tripled, then mass will decrease by a factor of 3. So they change by the same factor. Here's the overall short equation for Newton's second law, that A equals F divided by M. Okay, let's just apply that equation really quickly. If this man exerts a 100 Newton force on this 50 kilogram sled, then if we drop those values into this equation to solve for acceleration, it's just 100 newtons divided by 50 kilograms, and we get an answer of 2 meters per second as the rate of acceleration when a 100 Newton force is applied to a 50 kilogram object. Okay, then Newton's third law. This is a little bit creepy, but it's a really good example of Newton's third law. So Newton's third law is often called the action-reaction law, that for every action there's an equal reaction in force in the opposite direction. So if we look at this, he's standing on a skateboard. So what would normally be a recoil where the gun would pop back into his shoulder, in this case, he can't stand still because the skateboard wants to move. So when the bullet is pushed out of the gun, then there's an equal force pushed back on the gun. And since the man is holding the gun, then the man and the gun become a system. And so essentially, the bullet going forward pushes the man and the gun backward. So that's a really good example of Newton's third law.